Hey everyone, we're in section 6 looking at isotopes and average atomic mass. So let's get started. Isotopes are, again, this is review. This was in our previous notes. It is, of course, on the top of your guided note sheet. So just go ahead, fill it in quick, or you wrote it already. You don't have to, just listen, okay? So isotopes are formed when atoms lose or gain neutrons. That often is gonna happen during nuclear decay. We're gonna do nuclear decay later in the year, but during nuclear decay or where nuclear radiation comes from, usually that involves the loss or gaining of neutrons. It is gonna affect the mass. We've said protons and neutrons have mass, electrons do not. So while you can change electrons and change the charge, only changing neutrons is going to change the mass, because if we change protons, it's a totally different element, and that just complicates things. So when we're thinking about the mass of an element, there's two things to think of. There's the mass of the atom and the mass of all of the atoms of that element that exist in the entire universe. Okay? So the mass of one atom is going to be the protons plus the neutrons. That's why it comes out as a whole number, and it's referred to as the mass number, because you have 8 protons, you have 8 neutrons, you have a total of 16 units of mass, so the mass number is 16. But the mass that you see on the periodic table is a decimal. They all have decimals, which means that it's not all the same. And we've already seen carbon can exist as carbon 12, carbon 13, carbon 14, carbon 11. Different elements can exist in a lot of different isotope types. And so the average atomic mass is the weighted average of the naturally occurring isotopes that you're going to see for that element. So it takes into account how abundant they are. If you had carbon 12 and you said carbon 12 was 99% of the carbon, and 1% of the carbon was carbon 13, then finding the average mass of carbon would not be 12.5. 12 plus 13 divided by 2. Because 99% of the carbons are 12. So it should be weighting in that direction. It should be pulling in that direction. So as a result, we take into account their percent abundance. I'm just skipping that, we already saw it. So average atomic mass takes into account the percent abundance. So basically, when you're calculating average atomic mass, you take the mass number of isotope 1 times the decimal abundance. And I'll show this to you guys. Decimal abundance. Plus, and then repeat for other isotopes. Okay, I probably should have written this down before we started, but here we are. Okay, so this is essentially the quote-unquote formula. It's not really a formula, but this is essentially the formula for average atomic mass. It's a weighted average. We're saying, okay, we have isotope 1, which has a mass number of, let's just say 12, and 99% of that element is that. So we would say decimal abundance, that would be 0.99, basically the percent divided by 100, plus the other isotopes. Of course, when we're taking into account the decimal abundance, all of the isotopes together should equal 100%, or 1.0. And so we add them together, because we're saying, okay, well, of the average atomic mass, this is what mass, or this is what isotope 1 is doing, then we add that to what isotope 2 is doing, etc. So let's look at the example that's up here. Excuse me. Okay. It's on the next slide too, so I'll just go there. So we have carbon 12, we have carbon 13. So we're asked to figure out the average atomic mass of carbon 12 and carbon 13. So I'm going to say, okay, I have the average atomic mass for carbon, and it says isotope 1 is carbon 12 with a mass of 12.000. And it is 98.90% of the carbons are that. So I'm going to multiply the 12 by the decimal abundance of that percent, 0.9890. So that is 98% of it is carbon 12. Okay, and so I'm going to be taking that into account as I multiply it, but that's not all of the carbons, so I'm going to have to add, there's an insect on my, there's a lot happening. I'm going to add the repeating with carbon 13. 13.000. I know it says 003 on there. You know what? We'll do the 3, whatever. 003 times the percent abundance of 1.10, okay? Which is 0.0110. Okay. So there's only 2 isotopes, so I only need to add the 2 together, and I'm going to run that. I'm going to put it in my calculator exactly like this, including parentheses. We've learned already that a lot of us struggle with parentheses. So let's make sure that we do that. All right, so I'm going to run it in my calculator. Open parentheses, 12.000 times 0.9890, close parentheses, plus, open parentheses, 13.003 times 0.0110, close parentheses, enter. I get a value of 12.011, blah, blah, blah. First question, of course, to ask yourself, does it make sense? Well, yeah, because the answer came out to be 12.01, essentially. If we're going to do sig figs, what would that be? 4 sig figs, right? 3 sig figs. 1.10 is 3 sig figs. Yeah. So 3 sig figs. 12.0. So the average atomic mass that we calculated for carbon, 12.0, and that would be in AMUs, okay? Atomic mass units. Does it make sense? 12.0, we know that it goes to 1, blah, blah, blah. Well, yeah, if almost 99% of them are carbon-12 and only 1% of them might be carbon-13, then when I weight that average, it's going to weight a lot heavier towards 12. That makes sense. That's what weighted averages do. They pull in one direction the general average, the kind of generic average that would be there. So let's go back to the slides. We have 2 practice problems here. I'm going to have you just go ahead and run those as though you're just practicing. I'm going to do the first one, and then the second one you can do on your own, and then the practice problems on the bottom of the paper also can do on your own, okay? So this one, naturally occurring chlorine, has 75% chlorine 35, 25% chlorine 37. So calculating average atomic mass. I have my first isotope, which is chlorine 35, so I have the mass number 35, times the decimal abundance, 0.75, close parentheses, plus my second isotope. 37 is the mass number, times 0.25, close parentheses, equal, okay? So this is how I've set this up. 2 isotopes, 2 mass numbers, 2 decimal abundances. It's just the percent abundance divided by 100. Let's do it. 35 times 0.75, enter, plus, open parentheses, 37 times 0.25, and I get 35.5. When I check my sig figs, I should only have 2 sig figs, so I'm going to round that to 36 AMUs. Okay. All right. I was literally about to ask, does anyone have questions? Okay, well, if you do, please write them down on your paper now and ask me next class, okay? So go ahead and let's go back. Oh, I forgot this was here. Okay, so if you want to run the other one, for number 2 on the practice problems, it should be 13.6 AMUs. So if you want to write that down so that you can check your answer later, then you can, okay? Go ahead and summarize. Summarize your notes. This is an important step in the learning process because you say, okay, I just got all this information. I just wrote it all down. Does it make sense to me enough to put it in a sentence? That's a good thing to be able to do. So go ahead, write your summary, answer your 5 practice problems on the bottom of your paper, and I will see you guys next class. We'll start class by going over those practice problems, okay? All right, see you then.